Hello guys. So in our previous video, we have probably seen simple linear regression, multiple linear regression algorithms and all. And we have also seen how to train a model, how to probably pickle that particular model into a file and save it in the hard disk. Now for this series of algorithm, like how we can implement with the help of Python and sklearn, that is Ridge, Lasso and ElasticNet, I'll be taking a new data set because based on this data set, right, we will create the model and then we will also deploy this entire project into the cloud. Okay, so this will be a continuous series. So first of all, this data set that I've actually taken is basically called as Algerian forest fire data set. The dataset information is that the dataset includes 244 instances that regroups data of two regions of Algeria, namely the Bijaya region located in the northeast of Algeria and the Sidi Bel Abyss region located in the northwest of Algeria. Now here you have 122 instances for each region. So one of the region you specifically have 122 records, for the other you basically have 122. And the period is from June 2012 to September 2012. The data set includes 11 independent feature and one output attribute called as class. But since we are actually calculating or we are trying to solve a regression problem, so over here what we are going to do, these are all my features. See, date, temperature, RH, WS, rain, fine fuel moisture code, duff moisture code, this features are there. Now we are going to use this specific feature and try to predict what will be the temperature. Okay, because temperature will be a numerical continuous value. So this is why we are basically saying it as a regression algorithm. Now this specific regression algorithm will try to solve it with linear regression, ridge regression, lasso regression and ElasticNet, and we'll try to see that which will better give us a better accuracy. Now to start with, for this data set, here is the data set file. Okay, I will be giving you this CSV, and this initially we will start with something called as EDA. Now I'm not going to write the line of code, guys, because we have done this multiple of times. So let me just go ahead and explore and see, execute and probably explain you what all things we are basically doing in the EDA. So obviously initially to start with, we'll be importing all the libraries like pandas, numpy, matplotlib, seaborn. So I will go ahead and execute this. And then we'll go ahead and read this particular data set. The data set name is Algerian underscore forest underscore fires dataset underscore update.csv. So this will basically be my data.head. So here I have values like day, month, year. Then temperature is there, RH, WS, R, rain, FFMC, DMC, DC, ISI, BUI, FWI and classes. Now what did I say? I am going to create a regression algorithm which will predict temperature. So this will basically become my output feature and remaining all will basically become my independent feature. Okay, so this temperature will become my dependent feature. That is what we are basically going to do. Now to get the basic information about the data set, so these are the basic information. Here you can see that all the columns are of object type. Okay, that is not of numerical type. So what you're probably seeing over here, it is all string and object type. Okay, now with respect to the data cleaning, first of all, we need to check whether you have any kind of missing values. So for that, dataset.isNull.any with access equal to 1, I'll be seeing that there are two records which is basically having nan values. One is the 122 second record, that is this specific data point, and the other one is 167 where you have this class as nan. Okay, now over here, the information is that the data set is converted into two sets based on region from 122nd index. That basically means from 0 to 122nd index, it basically belongs to this particular index, right? This particular region, that is Sidi Bel, right? So what we can do is over here is that we can make a new column based on the region, right? So the first region is basically Bijaya region data set. That basically means from 0 to 125th index, it is basically belonging to the Bijaya region. And from 122nd index to the last, it is basically belonging to the Sidi Bel Abyss region dataset. So what I'm actually doing over here, I will basically write dataset.lock of till 122nd record. I will create a new feature called as region and I'll assign the value to 0. Why 0? Because it belongs to Bijaya region dataset. So for this region, I'm basically writing it as 0. For this region, that is after 122nd index, I'm going to basically write it as 1, which basically indicates Sidi Bel Abyss region. Okay, so in short, I have assigned labels like 0 and 1. Okay, now this is done, and finally I will be getting my data set. Now if I probably go and see my dataset.info, I'll be having one additional new feature which is called as region. Okay, and if I probably want to go ahead and see my df.head, you will also be able to see the df.head where I will be having this region which will be in the floating value. Now what we can do, we can probably convert this region into int type also. So here for that we will be writing df.region dot as type of int. Now see guys, now just by seeing the code you are able to understand, right? Because these things I have written it line by line for you all, right? And I hope you are able to understand. If you have practiced well, you will be able to understand. Okay, if you did not practice well, because see, in all my previous problem statement I have written the code line by line. Okay, now it is not possible that I probably try to write it everything with respect to line by line, otherwise it will take 2 years to complete this course. Okay, so now if I go ahead and probably check whether I'm having any null value or not, so definitely I have some null values over all these features, right? So we will try to remove the null values because there were only 2 records. So I will say df.drop na, and I'll do reset index with drop is equal to true. So if I go and see now df.head, now my null values has got removed, and if I probably go and see df.isNull.sum, all will basically become 0 values. Okay, so this is what we have basically done with respect to that, and we have also removed the nan values. Okay, now let's go ahead and see the 122nd location. So the 122nd location is basically having this particular value like day, month, year, temperature and all, and FMCC, and this is there. Okay, what we will do, we'll also try to drop this. Okay, because there are some special characters that is basically coming over here. So we will drop the 122nd row. In order to drop it, you just need to drop 122nd, and we need to reset the index. Okay, so here once we do this, now if I probably go and see my iloc 122, here you'll be able to see I will be getting the next data point. Okay, and now if I go and see my df.columns, so these are my df.columns over here. Okay, see, just it is so simple, right? I'm just trying to do the EDA. Now this is very much important. Over here, if I write df.columns.str.strip, okay, and if I go ahead and see df.columns over here, you will be able to see that I will be getting all these values, right? So this str.strip, what it is doing is that it is removing this empty spaces if there is any in the column, right? For that purpose, see, there are some empty spaces over here, there are some empty spaces over here, and if I need to remove from this particular column, I'm basically writing df.columns.str.strip. okay, and that is the reason now I will be able to get all these particular feature names without any empty spaces. And finally, if I go and see my df.info, this is obviously region is int type. Okay, now we need to convert all this object type into the int type, right? So first of all, change the required columns as integer data type. I'll go and see my df.columns, and now this month, day, year, temperature, RH, WS, right? These all features we will try to convert it into int. Okay, so if I now go ahead and execute and see the df.info, all these features have actually become int. Okay, so till here WS has become int. Okay, and then we need to change the other columns to float. Why other columns to float? So if I probably go and see df.head, so till here, till WS we converted into integer, but these all values are floating values, right? But it is in the form of object type. So obviously we need to convert all these features which is basically belonging to an object type, okay, into floating point numbers. Okay, so that is what we are basically going to do, changing the other columns to float data type over here. So I will be getting all the features. Feature for df or organism this dot data types is equal to object. I will get all the objects over here. So if I probably go and execute this will basically give all my column names that are basically objects. But understand over here, this last one columns, right? It is a categorical column. It needs to be in the form of object. And for this, we'll be doing one-hot encoding, right? In that we have basically learned in the feature engineering, right? Because this class is not fire and it is basically fire, right? So I will say for I in objects, if I is not equal to classes, then only I will try to convert that into float. So once I do this, and if I probably see df.info, remaining all the features till here, till WFI has got converted into float, right? From rain to WFI has been converted into float. Okay, and finally I have region. Now still I have that classes feature, which is basically object type. Okay, now let me go ahead and see this. Now if I go ahead and write df.describe, I'll be able to see the summary statistics of all the numerical features. And if I go and see df.head, I'm getting this. Finally, all this cleaning of the dataset that we have done, we'll try to save it in a CSV file, which is called as Algerian forest fires _cleaned _dataset.csv. Okay, so that we have saved it. Now if you probably go and see over here, you will be able to probably just will take some time to get refreshed, and this particular CSV file will get saved in this name. So here is my CSV file name. Okay, So if I probably see this, it is basically saved over here. No, this is not the data set. This is the data set. Okay, clean data set. And this is what it is basically saved. After doing the data cleaning, we have saved it over here. Perfect. So till here, everything is going fine. And now we will go ahead and do the exploratory data analysis. Now, in order to do the exploratory data analysis, what I've done is that initially, let's go ahead and drop day, month, and year. Okay. So I'll be telling you why we are doing this. And now if I probably go and see this, because I'm going to use only this input features, date will not play a very important role, right? With respect to the prediction, because all these features, all these features will basically talk about like what the exact temperature is, right? So what we are going to do, we are going to take RH, WS, rain, FFMC, this all values till region, and then we'll try to predict the temperature. Okay. So now if I go and see categories in the classes, right? So for this particular classes, how many categories are there? So here you'll be able to see fire, you have 131 rows. You basically have that. Not fire, you have somewhere around 101 rows. Then again, fire, this different name is there. See, fire 42, then not fire. Probably a spaces has been added. But we really need to get only two types of categories, that is fire and not fire. So what I will do is that we will simply say that df underscore copy. So I will put the np.where clause, and I'll say df underscore copy of classes dot str dot contains not fire. If it contains not fire, make it to 0. Otherwise, make it to 1. So I'm saying that wherever there is fire, right, as my output, as my categorical feature, make it as 1. Remaining all, you try to make it as 0. Okay. And that will basically get saved in the classes. So this is what np.where condition is. Okay. And now if I go ahead and see df underscore copy dot head, you will be either getting zeros and ones. Okay. So if I go and see df underscore copy dot tail, again, this will be 1. Okay. Ones or zeros. Okay. Most of the time. And if I probably go and see value underscore counts, now number of ones is nothing but 137 and number of zeros is nothing but 106. That basically means 137 data points has one value over there and 106 data points has 0 values. Okay. Now we can go and probably plot our histogram plots with respect to all the features, since we are using the numerical feature, and probably this will take some time of execution. So this is how you'll be able to see with respect to the histogram your data points are. If you want to probably see with respect to the classes, how does it basically looks with respect to the pie chart, then first of all, I can probably calculate the value counts. I can calculate the percentage, and after that, I can probably go with plot.py, right? So this same percentage I'll be using over here. Labels, I'll be using the class labels. Class labels is fire and not fire. And by using auto percentage, we'll be able to get in the form of percentage. So this is what you'll be getting it, right? It's all about execution, guys. See, you may be thinking, Krish, you are going very fast. See, guys, EDA, I told you, right? You can only be perfect when you practice more and more. If you are able to see this many problems we did in the previous classes, right? Now, I expect you all to that just by seeing the code, you should be able to understand. Okay. So this was with respect to this. Now we will go and see with respect to the correlation. So this I will make it as a markdown. Now this df underscore copy dot correlation, if I try to see with respect to the numerical features, here we are getting the Pearson correlation by default. What one feature with the other feature, what is the correlation? Here we are able to see this. Okay. If I want to see with in the form of heat map, I will also be able to see in the form of heat map. Here I will basically use anode is equal to true. So we are just doing EDA. Okay. So here you'll be able to see all these things and what is the value, what is how much correlated it is, right? All these things are there, right? Now, if I go down, if I want also see the box plot with respect to any features, I can see the box plot. This basically indicates the outlier, right? So again, this df.head. Now what we are doing over here is that I think np.where df of classes dot this. I think this is fine. I'm just trying to find out np.where df of classes dot contains this. I think we can comment down this particular code. It is not at all required. Now what we'll do is that we will try to do the monthly fire analysis. For region 1, we will try to plot the count number of fires that is going to happen based on month and the classes, that is 0 and 1. Okay. And the data set that I'm actually giving is my df. Okay. A df underscore copy also I can basically give. I think it is df underscore copy. Okay. So yeah, I will basically use df underscore copy over here. So I will be just write df underscore copy. Perfect. Now if I execute this and I'm getting an error, let's see, could not interpret the input month. Okay, fine, then I will give df because I did not remove all those things over here. So finally you can see that with respect to various months, this is how your number of fires are there. So for the 6th month, number of fires was here, then it was here for the 7th month, right? And what are the categories that you will be able to see this? Okay, I will just remove this and I will just say that np.where where df of fire contains not fire, I'm just going to replace with not fire, otherwise we are going to replace with fire. Okay, I'm not converting into numerical feature over here. Now if I go ahead and execute it, I will just get this not fire and fire. Okay, that is the reason I think I changed it to not fire and fire. So over here you can see for the 6th month, number of fires over here are there, and this is basically for the green. Green is basically fire and blue is not fire. On the 7th month, the fire was more because obviously those are the summer season. In the 8th month, you can see the fires are still more, right? Forest fires. And in the 9th month, the fire were less. So basically 6th, 7th, 8th month, you'll be seeing that the number of fires is increasing. Why it may be increasing? Because that is the summer season, right? During this particular time. Similarly for 0 region, right? If I really want to see with respect to the same thing, here I will be able to see the fire analysis. Again, here also you get the same observation. 6th, 7th, 8th month, you are getting more fire than compared to not fire. Okay. So observation is that it is observed that August and September had the most number of fires for both the reason. And from the above plot, we can understand few things. Most of the fire happened in August and very high fire happened on only 3 months, that is June, July, August. Less fire was on September. So this was the observation that we can specifically make. So this in short was the entire EDA with respect to the Algerian forest fire dataset. Now all I'll do is that whatever dataset we cleaned and saved it, right? We are going to apply linear regression, elastic, ridge, all the algorithms over there, and we'll try to find out the R squared, adjusted R squared, MSE, MAE, right? All those things, and we'll also see that how we can pickle that specific file. So yes, this was it from my side with respect to the EDA of Algerian forest fire. Now in the next video, we are going to implement one by one ridge, lasso, and elastic net along with the linear regression. So yes, this was it. I will see you all in the next video. Thank you.